All right, we'll get started just to keep up on time here. So thank you everyone for joining. My name is Charlie Carpenter. I'm with Efficiency Vermont. We have Barry Murphy presenting as well from the Vermont Department of Public Service. And today's webinar is going to be on state, local government agencies and energy committees and how the commercial building energy standard relates to your work. So I'll give a brief intro right here, and then Barry's going to go into some of the history behind what the commercial energy code is, how often it's updated, and different government agencies involved with that. And then I will dive into some of the brief overview details of the code and aspects that I think will be useful to everyone who's on the call. Just a reminder, I think everyone's on mute, so if you need to chat, I'd say first post something in the chat box, and my colleague Bryn is going to be monitoring that, and if there's any questions, we will try to answer a couple as Barry and I are presenting, and any other ones we'll save towards the end. So please type in there, and we can unmute you if needed, if you've got more questions. So, and Bryn wanted me to remind folks that next Friday at 9:30 a.m. there's a similar presentation scheduled in relation to the residential building energy code. So if anyone would like to attend that one as well, I think we'll post a link to that registration in the chat here. So I think I've got it all here. So I will pass it off to Barry to start off with his portion of the presentation.
Okay, let's make sure I get the right screen up. Okay, hopefully at this point everyone can see just the title screen and not actually all my notes. So my name is Barry Murphy. I'm with the Public Service Department, and I have been there for over 10 years, and I have gone through the code update process 3 times now in the time I've been there, and it's always a lot of fun, as I'm sure you can all understand. There we go. So the commercial code, as you can see here, came into being, as it were, in 2006, and you can see where it's codified, etc. It applies to all commercial buildings and any residential building that's over 4 stories or more. And that means that's above grade. So if it's got underground parking or a basement, or they've got people living underground, technically those stories don't count. It's a weird quirk. I'm not sure that we have many basement dwellers really in Vermont, but perhaps we do. But prior to the 2006 passing of the CBES, we did have from 1997, I believe it was, or maybe in 1998, a guideline for energy efficient construction, which mostly applied to Act 250 buildings. But in 2006, during that period, basically, it was decided that they would codify both the residential and commercial codes into law. So currently, our code is the 2020 CBES, and that applies to all new construction and renovations and additions, etc., that take place within Vermont. And certain Act 250 projects, due to how the permit process is structured for that work, can still meet the 2015 code, but they also have to meet the 2015 commercial stretch building energy guidelines, which is over and above what is in the 2015 commercial code. Most of that was actually folded into the 2020 version, which is why there's not a stretch guidelines for the 2020 version, because, as I said, we included many of the recommendations from the guidelines into the code itself, which would include EV charging, solar ready, that kind of thing. So what does CBES apply to? Well, it's easier to say what does it not apply to than anything else. So basically, if it's a residential building and it's covered by the residential building energy standard, obviously it wouldn't apply. Low energy buildings. Oh, I just realized I messed up the slide there. Never mind. I'll fix that for the slide deck that you'll have access to. Low energy buildings, basically, if the building uses lower than 3.4 BTU an hour per square foot, which is really low. That's kind of like passive house standard almost, which would be difficult to necessarily do currently with the residential buildings. Unconditioned buildings, which basically means you're not heating or cooling the space. Greenhouses, no, it seems kind of obvious. Although the 2021 IECC, which these codes are based off, will start to regulate those. But since Vermont law actually specifically exempts agricultural buildings for the most part from having to meet the energy codes, that would not be included. Inflatable buildings. I've seen a few of these, generally used for over winter, but you know, I'm never seen an inflatable office, but maybe it exists. Yurts. It seems a bit of an odd exemption, but believe it or not, people are using these for commercial space, and you know, as a tent, it's really hard to make it meet the commercial energy code, which is why we created an exemption, but no, it has specific requirements. No mechanical cooling, and no, you can only heat it from essentially a renewable source. And the final exemption is equipment buildings, which are intended to be relatively small, not intended for extended human occupancy, with a relatively small heating system, mostly there to just maintain condition within the space for like equipment or something that needs to be kept above freezing or at a specific temperature. So basically, that's what CBES doesn't apply to. Just about everything else it would do, unless, as I said, it's a residential building. Now, how does CBES and the state energy goals kind of interact? It's kind of a yin and yang approach, I guess. They both inform and inform each other. A great example of this is electrification. Basically, prior to the 2020 code, there was very strict guidelines on what you could do in terms of using electric resistance to heat a space. It was basically prohibited except under great conditions of hardship, or it's just hard to heat it in any other way or fashion. The 2020 code as it currently stands includes specific exemptions around using electric resistance heat. For example, multifamily buildings can be exempt if their heat load is less than 6 BTU per square foot per hour. I think it is per year, something along those lines. Forget the exact number. Or if you're using heat pumps that would need electric resistance backup heat, as long as your envelope is better than, I believe it's 2.5 air changes an hour. Well, the standard was 3 air changes an hour at 75 pascals, which probably doesn't mean much to you people, sorry. And obviously, within the comprehensive energy plan, there is a stated goal to get to net zero ready construction by 2030. Which obviously informs how we have to try and structure the energy codes to try and make sure that we achieve that. That is difficult because there's a lot of other aspects that have to come into consideration, not just writing a energy code that would meet that goal. We have to also make sure that everything that we do is considered to be cost effective, which can really make it difficult when you're looking at it in terms of overall paybacks, etc. We could basically have said in the 2020 code that everyone had to meet almost passive house standards, but that would have been difficult, to say the least, to justify, because it really wouldn't have been particularly cost effective at that point. So it will take several iterations of the code to get to that point. So basically, the code gets updated every time the IECC, which the code is based upon, gets updated. The IECC is typically on a 3-year cycle, but this past year it's been delayed a little bit. So it's only just been published as of January 2021, which means that we will be looking at updating, starting the update process again at the end of this year. But the earliest that update would come into effect would be January 1st, 2023 at this point. It may actually be later, and we'll get to why that is in the next slide. So basically, the current code came into effect in 2020, in September 1st. And it took over a year of basically stakeholder meetings and then public hearings, etc., and going through the rules process in order to get the code adopted. And then there's a minimum of 3 months after the code is adopted for it to become effective. We actually delayed that from 3 months to 9 months to make sure that we had all the supporting materials and computer software, etc., prepared, so that when the code took effect, you know, for some reason my Alexa started to talk to me. All the materials were ready, and we had everything ready to go, so that, you know, there was no one looking to have the software or anything else that they need in order to support the designs. So basically, the process is we will start by reaching out to interested parties. Those are generally builders, engineers, architects, advocates for low-income housing, and basically the meetings are open to anyone who wants to take place. We do post these meetings on our website. We do extensive email outreach, etc. But we can't reach everyone. So if you want to be notified when we're doing the next kind of update cycle, if you would email me or email the department, we'll make sure that you're added to the list to be notified when we start the process and when the meetings, etc., are going to take place. But as I said, it's an extensive stakeholder process. It's iterative. So we go through multiple revisions of the code updates, and we seek feedback from the people, either via email or in the specific meetings, or, you know, in any other kind of forum that we can take it. And basically, once the code is finalized, or what we consider final, we then have to go through the rules process, which has a defined period of time that it has to take place. I believe it takes, the quickest you can really go through the rules process is about 3 months, which includes multiple public hearing and opportunities for other people to comment. Let me see. So that's really the code update process, and as simply as I can try and explain it, it takes a year, if not longer, in order to go through this. And if you really are interested, then we can certainly make sure that you're included in our outreach efforts, so that you can provide comments and thoughts on the next update. So what role does the Public Service Department have as far as the Energy Code goes? Basically, we are mandated by the 30 VSA 56, I think it was, or 54. I said at the beginning of the slides, we're basically required that we update the code, but we are not considered the authority having jurisdiction, and we are not given the authority to enforce the code. The CBES as a whole is a sort of self-certification process, which basically means that the builder and the architect and any other like mechanical lead or whatever, they have to provide a signed affidavit saying that they designed the building to meet the CBES that's in force at the time, and then the builder has to also sign a affidavit that says that they built the building to the architect's design. As a result, it can get a little bit complicated because you have to have 2, sometimes 3 or more people actually signing affidavits, depending upon how the construction is actually organized. And those certificates and affidavits also have to remain with the building records. They have to be posted either on the electrical panel or HVAC panel in the building, and a copy of them also has to come to me. As a little bit of an aside, while I said that the Public Service Department doesn't enforce the code, the Natural Resource Board does enforce the code for Act 250 purposes. However, the way it works for them is that they don't do inspections, etc., unless there is a complaint made about the building or the construction, in which case they'll send out someone to look at it and determine whether or not the complaint is valid and whether or not they're actually following the provisions of their permit, which would mean that they would have to meet the Act 250 and CBES code requirements that are in place. Another slight wrinkle there is the State Historic Preservation Office can provide exemptions from specific sections of the Energy Code if the building is deemed to be of historical nature, if it's on like a local or a state or national historic preservation list, or even it's determined that it should be. They can look at what you're doing and they can make a determination if insulating a wall would kind of materially impact the historic nature of a building, then they can exempt you from that. Same for windows and any other kind of mechanical pieces. So there's a lot of different kind of interactions within state government as to who actually can exempt and who actually is enforcing various sections of it. To the local government roles, as I'm sure you're all aware of Act 89 from 2013, which basically laid a lot of requirements on like zone administrators in towns, especially those that issue a certificate of occupancies. That basically require that the only time a certificate of occupancy can and should be issued is if a completed CB certificate has been entered into the town's land records. Also, as part of that act, zone administrators or zoning administrators were required to provide access to code-related materials at the time that someone came in to look for a permit. That could be anything from actually handing them a physical copy of the book. I believe some places provide links, etc., to where they can access it online as well. It's a little bit of an interesting piece. Cities and towns can elect to inspect and enforce code compliance to the CBES code if they wanted to. I believe in some cases that might require changes to town charters, etc. But it is an option that is available to them, since the state is not currently empowered to actually enforce the commercial building energy standards. Another interesting piece is that cities and towns can actually adopt a different standard from the commercial building energy standard if they choose to do so. The only requirement being that that standard be just as stringent if not more so than the current version of CBES that's in place. Which means every time we update CBES, you would have to look at your standard and make sure that it at least minimally meets the requirements of stringency as far as the CBES goes. On the department's website, we have lots of resources for you as far as the commercial building energy standards goes. We have links to viewable versions of the energy codes. We have the links to the CBES certificates and affidavits. We have the historic building exemption form. We have the links to the commercial building, the ComCheck compliance software. We also have a broken out by section training videos that will go over and explain a lot of the intricacies of the commercial building energy standards. If you're really interested in, I think they're probably about 4 hours long in total, if you were wanting to watch them all. I would personally recommend chapter C406. It's enthralling. And we also have on our website links to all the previous versions of the energy code and all the related energy materials for those, just in case for whatever reason that you need to go back and make sure that the building actually complied with energy standards or energy codes, or for whatever reason. We don't generally see much of that in the commercial side, but we certainly see a lot of it in the residential side, where a certificate has not been completed and they need 2015 or 2011 or even something earlier than that to show that they complied with the energy codes. So we still have all that historical material available should it be required. So much beyond that, that's my information there. So you can reach out to me if you want to get added to our contact list so that we can inform you when we start the code update process. And you know, I've been talking at you for what is that, 5-10 minutes? Oh, 10 minutes, that's not bad. So if you have any specific questions that you have or have been asked, then do so. If not, then I can certainly answer questions at the end once Charlie's finished his section of the presentation. And for the moment, I will stop sharing my screen. There we go. And I will pass it back to Charlie.
Great, thanks, Barry. I will share my screen now, assuming we don't have any questions at this time. All right. So now I will go over, sort of as brief as I can, a overview of the commercial energy standards. There's obviously a lot. There's some information I left out. So if you have specific questions on a certain aspect of the code, you can contact me. I'll have my contact info on the last slide here, and we're happy to help answer questions for designers or architects or local and state officials as well. So first I need to read this disclaimer as I'm using information directly from the code book. This material contains information which is proprietary to and copyrighted by International Code Council, Inc. The information copyrighted by the International Code Council has been obtained and reproduced with permission. The acronym ICC and the ICC logo are trademarks and service marks of ICC. All rights reserved. Okay, so these are the sections within the commercial energy code, and I will touch on sort of the highlights of each of these as quick as I can. Administration definitions, envelope requirements, mechanical systems, service, water heating systems, lighting, the additional efficiency packages, C406 that Barry mentioned is so exciting, commissioning, and existing buildings. So in the administration section, as Barry mentioned, the 2020 commercial building energy standard became effective on September 1st of last year. So what this means is if you had a project that had already applied for or obtained its building permits before September 1st, then it could actually still be built, designed and built under the previous 2015 energy code. And if it applied or obtained permits after September 1st, then it should be using these updated 2020 code numbers. And the code states that a permit, it's either a building permit or Act 250 permit that is applied for to trigger this date. Barry also mentioned there are no stretch guidelines for the 2020 energy code as there were in the previous version. So what that means is any Act 250 commercial projects will now just need to follow the standard requirements in the energy code and not look at the updated, more stringent stretch guidelines. From the link that Barry sent from the Public Service, Department of Public Service website, this is a snapshot of the Commercial Building Energy Standard Certificate. Just figured I'd show this. So there's, we've got a certificate where you put in some of the building information. There's also, as we'll go into, you would select which energy efficiency package packages you have included in the building. So that would be, I think, an important thing for local government agencies to review and discuss with the building owner and developers. And this needs to be displayed within the building and also sent to Barry at the Public Service Department. And again, there's the two affidavits that need to be signed. There's the construction affidavit saying that it has been built to the code standards. And then right after that is the design affidavit saying that it has been designed by or designed to meet the commercial energy standard levels. The also on the Public Service Department link, whomever is filling out that certificate, it could be the owner, it could be the designer. They also need to, there's some compliance documents that would go with that certificate, and that those are filled out with this ComCheck software that comes from the U.S. Department of Energy. And there's a specific Vermont 2020 energy code selection in there that I'll show. And basically you input what your envelope mechanical, electrical levels are for the building and the equipment that you use. And then there will be reports generated stating whether you don't meet or exceed the energy code. And that is a little more detailed compliance paperwork to send to Barry as well. So this is what the web version of ComCheck looks like. As I mentioned, it comes from the DOE, so there's multiple codes in here, but you would select the 2020 Vermont code to use here and make sure that is what is being submitted for projects going forward that need to follow the 2020 energy code. Okay, moving on to definitions. Just there's a bunch in the code, but these are a couple new or useful ones that I wanted to share. So when you have a mixed occupancy building where you've got both commercial and residential applications happening at the same time, if it is 3 stories or less in height, you'll both the commercial and residential energy codes will actually come into play. So any residential only spaces, the living spaces, dwelling units, hallways and laundry rooms and storage just for the residents would actually need to follow the residential code. And then areas that are commercial only or serving both commercial and residential uses would need to follow the commercial energy code. And then if you have a building that is 4 stories or more in height, then it is all, even if it's got some residential uses in there, the commercial energy code will apply for all areas of that building. There's a definition for what on-site renewable energy can include. And so we've got solar, wind, landfill gas, biogas, biomass, so that's burning wood, and geothermal energy. There was tidal on here, but I took that off because I don't believe that makes much sense in Vermont. And a new definition for this code is a semi-conditioned space. So this is a space that is heated or cooled to a much lower threshold than a standard building would be for human comfort. And there's numbers here for what you would need to reach. Must be below these in order to be considered a semi-conditioned space. And really it's only, say, warehouses and some big storage rooms that might be heated to, say, 50, 55 degrees and maybe have no cooling or just extremely limited cooling that would fall into this. So it's not very common. But what it does is if you have a semi-conditioned space, there basically all the envelope requirements, the R values are about half as much as what the standard insulation levels are. Okay, so I'm going to move on to what those envelope requirements are for the new code. And these are the major changes. So some of the R values have been updated. Windows and skylights have been improved a bit, and there are now new air leakage requirements for all commercial buildings and also for dwelling units within commercial buildings. So for the roof insulation, these are the new R values that will, if you do at least this, if not more, then you will meet the energy code. I believe the attic insulation is about the same as what it was in the previous code, but the insulation above deck, so if you've got a metal building or a building with all continuous insulation up on a flat roof, that has increased. And then metal buildings, you've got different layers of insulation going parallel to and perpendicular to the roof framing members. That's what all these different numbers here mean. But basically, they're all a much closer match, depending on no matter what the building type is, whether it's attic installation, metal building, or all above deck. It's a much closer match in this code. Any above grade walls, similarly, the insulation values are now a closer match. So you've got different, depending on if you've got a concrete or a brick wall, metal building, a metal framed building, or a wood framed building, you've got different, some slightly different requirements for each of those. And all of these now require the CI is continuous insulation. So that's typically, rigid foam or rock wool or some other insulation that is continuous, typically on the exterior, sometimes on the interior of the wall, that is uninterrupted by framing. So it's, as it says, it's continuous. So now all types of walls require some amount of continuous insulation in order to meet the code. Below grade walls, that is, you need to meet R15 continuous insulation. That can be, again, either on the inside or outside of that wall. And for floor or slab insulation, we've got a few different options here. What I want to call out as the biggest change are the last two. So for unheated slabs and heated slabs, you need insulation under the entire slab. So an unheated slab is R10 under the entire slab, and a heated slab is R20 under the whole slab. Previously, it was just either around the perimeter of the slab and or down about 4 feet. So that's been changed to be under the whole slab now. Windows and skylights. I've got, they mentioned what the U factors are in the code, but I've changed those over to R values, equivalent R values on the right. So it's a little easier to understand. So fixed window of about R3 is at least is required. If you got an operable window, it's a bit lower, R2.7, and any entrance doorways R1.5. And skylights are about R2. There are also requirements for, it's about 30% window to wall ratio is what's allowed for commercial buildings. There's a couple ways to increase that if you need it, if you need to have more higher performing windows, but 30% is standard. So the other change that happened to the code that I think is pretty important is there are 2 different ways to comply with air barrier performance, or for the air barrier of the building. You can either test the building with a blower door test and hit a specific number, and then you would pass that portion of the test. Or you could do air barrier commissioning, where you have someone come in and there would be at least 1 blower door test throughout it, a bunch of other items on a checklist, smoke testing certain portions of the building, but you do not need to hit a specific number. The thought is if you do all these items, you are most likely to hit a good air barrier performance number. So I think most buildings are going to go with the first route, just the testing route, where you test it at the end, and if you hit the number, you're good. If not, then you need to go back and make some modifications. So the new standards are 0.3 CFM per square foot, and that is measured. The 75 there means that it's tested at 75 pascals. You depressurize the building to that amount, and that's where you measure the air leakage. And the square footage number comes from a 6-sided envelope. So in this version of the code, you'll add up everything, all the walls above and below grade, the slab or basement, and roof. The previous version of the code was we were only testing at 50 pascals and using 5-sided surface area calculation. So it's not really comparing apples to apples, this version of the code to the last. We've got some numbers, if you want to compare those, we can help out with that. But this is how the commercial industry around the world, it's more typical to do the 6-sided and 75 pascals. So I think that was a good change. And if you've got a large building over 50,000 square feet, there's some rules in there about just portions of the building you can test. You don't actually need to do all of the square footage of that building with the blower door test. And the dwelling air unit infiltration. So if you've got a commercial building with multiple dwelling units in it, you actually need to put a blower door on some of these individual dwelling units and see how airtight they are compared to their neighboring dwelling units. So it's those must hit 0.35 CFM, again tested at 75 pascals, counting all 6 sides of that dwelling unit. You've got to test about 10% of the dwelling units in each building. It's got to be random. The construction contractor won't choose them. And these must be retested if there's a failure until they pass. So this is a bit more strict, where you must hit that number and go in and do whatever's necessary to do that. All right, on to mechanical systems. Bryn, chime in if there's any questions, but I'm going to assume not and just keep rolling. So the Commercial Energy Code references one other code, which is ASHRAE Standard 62.1, which is ventilation for basically indoor air quality. And what that states is that buildings cannot use just natural ventilation any longer. It can be a part of the ventilation strategy, but you basically need some sort of mechanical ventilation system to both exhaust and supply air to a commercial building. So that's, I think, pretty good to call out. Just baseboard heat and windows won't cut it anymore. Barry mentioned a bit about this, the electric resistance. So overall, electric resistance heating is still prohibited in this version of the Commercial Energy Code, as it has been for the past couple iterations. But there are two new exceptions that that I want to discuss. So one of them is if you have a multifamily building that has really low heat load requirements, and those are 6 BTU per hour per square foot at the design at the coldest temperature that that building should see. So if a multifamily building meets that requirement, you could use electric resistance only to heat that building. So that it's just such a low load that it's not a huge demand to use the electric resistance. It can do a lot of work there. And the other exception is for all other commercial buildings, you can use cold climate heat pumps with electric resistance backup. So the cold climate heat pump must be able to meet all of the heating load down to 5 degrees Fahrenheit outdoor air temperature, and then below 5 degrees, you can have the electric resistance heating turn on, and that needs to be, those need to be two different control systems to make sure that the electric resistance heat will not be on above 5 degree outdoor air temperature. And in order to do that, you must have a tighter building envelope. So instead of the 0.3 CFM, which is the standard for all buildings, if you get it tighter down to 0.2 CFM, then you can use the cold climates with electric resistance backup heating. And just a note, if you're in Burlington, they ask that Burlington Electric Department asks that you ask for approval for installing these before going ahead. There's a bunch more in the mechanical section, but I'm just going to share this one other slide. Basically, there's tables in there for what the minimum efficiencies are for multiple types of equipment: air conditioning units, heat pumps, chillers, VRF, heat pump systems, furnaces and boilers, and some others. So basically in the code, there's the minimum efficiencies. Here's some boilers showing between 82 to 84% efficiency. That's, the code says that is the lowest that you can install. And then there's options that are more efficient than that on both the heating and cooling equipment. So now I'll just mention, so this is service hot water, domestic hot water in a commercial building. Just got one slide on this. So the changes that happened here are the maximum size of individual electric water heaters increased from 5 kW up to 7.5 kW. And if you have a heat pump water heater that also has electric heating element within that, there's no limit to how large that electric resistance heating element can be. If you meet these items, 60% of the hot water comes from just the heat pump and not the electric resistance. if you've got low flow shower heads, and any dishwashing equipment is Energy Star rated so that it uses less water. So those are two new additions that I think are we're going to see utilized more often in this version of the code. Now I'm going to move on to lighting systems. There's a lot in here as well, so I'm just kind of touching on a couple points. For the lighting systems in buildings, it basically starts out on the controls side. It states that occupancy controls are required in a good number of spaces. So if this was an office building, almost a majority of the spaces, I'm not going to read them here, but they're listed, would require occupancy controls that would turn the lights off after at least 20 minutes. And there are daylighting controls required in areas, adjacent to windows and under skylights, if there's more than 150 watts of lighting fixtures that are within those daylighting zones. So that can be a good number of spaces as well. If you've got a restaurant or shopping area, the first floor of those don't need the lighting controls, and some other areas like healthcare facilities are exempt from that as well. This gets a little numerical here, but there's the lighting power density is how the code determines if a building meets the energy code or not. So basically that is just the number of watts from lighting per square foot of building area. So that's what all these different numbers are. It's the watts per square foot of lighting in these types of buildings. So this table is from the code. We've got the 2015 version and the 2020 version, and the percent reduction from the watts per square foot allowed in the 2015 to 2020. So, and I just listed, there's more in the code, but I listed some of the most commonly seen building area types in Vermont. Basically what it comes down to is it was about a 25% reduction from the old code to the new code. That's still attainable. Efficiency Vermont is recommending even 20% better than the new 2020 levels. That's very possible with LED lights. So there is still room to exceed this. So this is looking at a full building based on the type. There's another strategy. I won't go into too much detail, but you could look at every single space within a building and see if those all add up to meet the energy code values. So again, there's a even more extensive table that I took a snapshot of that has the watts per square foot for different spaces within a building: offices, warehouses, corridors, conference rooms, etc. So some of those went up, or some of those stayed the same. Some got more stringent. Again, overall, if you kind of average them together, the reduction was about 25% more stringent lighting for 2020. So that's interior lighting. Moving on to exterior lighting. This one's done a little bit differently. What you start with is there's 3 different types of lighting zones that buildings can be located in within Vermont. I'll start with zone 3. Zone 3 are basically like Vermont's downtowns and city centers, so where there's a lot of lighting already in place. That's one lighting zone. Zone 2, I think, is the most common, where you've got both residential and some commercial areas happening next to each other. And Zone 1 is pretty rural, undeveloped areas within national parks. I think some ski areas, if they're not that developed, could be included in that. So the reason we have those zones is similarly, there's an exterior lighting power density allowances based on what different things you have outside of your building that you're illuminating. And you've got the 3 different zones here. Basically, you've got parking lots. That's one that's pretty common for all buildings. You've got a very small watts per square foot allowance for those. Walkways, dining areas, stairways, landscaping, loading docks, etc. There's more to this table. So things are measured either by watts per square foot or watts per linear foot for walkways. And these have been reduced about 50% from the previous code, but using LEDs, you can still, again, Efficiency Vermont is recommending between a 20 to 30% improvement over these levels, which is still attainable. And the last part I'll talk about for electrical is electric vehicle charging stations. So this was a new addition to the code. Basically, what the code says is, I'm going to show a table on the next slide where you calculate the number that you need based on the parking spaces you have in your commercial building. And the code states that you need to, whatever that number is, you need to install 50% of the electric vehicle charging stations and then pre-wire the remaining 50% so that you, down the road, you could install the charging equipment, but you don't have to install all of them when the building is first built. So you need to, those parking spots with the chargers need to be labeled for EV use only to distinguish them from the other spots so that gasoline cars don't park in them. You've got level one and two, and fast charge requirements that are split up in the numbers, and you would combine the level one and level twos together if you were only going to do level two or fast chargers on site. So this is the table from the code. So basically, depending on the type of building that you have, which is on the left here, and the size of the parking lot, it determines how many charging stations you need. So groups A and M, M is merchandise, that's like a sales type of building. B is businesses, education, so schools. I is industrial type buildings, and then R1 and 2. R1 is hotels and motels, and R2 is apartments and dorms. So just going through an example here, I think is helpful. Say you've got a hotel being built, that's group R1, and it's got 100 parking spaces. So when you look at the table, there are, for over 25 parking spaces, there's an option A and an option B. So if we look at option A, it says that you need 0% of the spaces should be level 1. So that's easy. And 2% of the spaces should be level 2 or DC fast charge. So 2% of 100 is 2 parking spots. And again, the code says that you need to install 50% of those and pre-wire the other 50%. So with option A, you need to install one charging station and pre-wire one other. So then if you look at option B, it says that you need 1% of these spaces to have level 1 chargers. So 1% of 100 is 1 spot, and 10 total spaces to be level 2 or DC fast charge. So again, only need to install 50% of those, but you need to round up. So you would need to install 1 level 1 charger and 5 of the level 2 chargers, and then pre-wire the remaining 5 level 2 charging stations for future installations. So I think that's a new one that a lot of owners and developers are going to be asking about, or hopefully remembering to do for their commercial buildings. All right, so moving on here. After the whole code is, you follow everything in there, there's this section C406 that's called additional efficiency packages, and there are 10 different, you need to get 6 credits from these 10 different options for a new building, and they all sort of vary based on the type of building that you have. So I know this is a little hard to read here, but this is straight from the online code. You've got your different types of building on the top, R1 and R2. So that's hotels, motels, and apartments and dorms. You've got businesses, B, education, E, merchandise sales areas, RM, and all others are the last column. So there's options. I'm not going to go into all the details here, but 15% more. The first one is 15% more efficient HVAC equipment. The second one, there's two options for doing either 10 or 20% reduction in your lighting power density values. You've got enhanced lighting controls is the third one. The fourth is on-site renewable energy. I think I'll have an extra slide on that one after this. The fifth one is a dedicated outdoor air system on the HVAC side. You've got three options for water heating. Again, those are only for high water use types of buildings like residences, the R1 and R2s. You could have a more insulated envelope that can give you some points, tighter air infiltration values for the building, more efficient kitchen appliances, and controlled receptacles that you would plug computer, office equipment, other things into that'll shut off when there is no occupancy around. So again, you need to get 6 credits for a new building. So there's only a couple here that have 6 on them. So most likely a building is going to have to do a couple or a few different options in order to reach the 6 points to meet the code.
Charlie, we do have a question or two when you get a second.
Okay, yep. I've got 2 slides here on this, and then I'll take it after that.
Great.
So I just wanted to go into a little more detail on the on-site renewable energy, because I think people will be interested in that. So here's the table with blown up a little bit more on the left, upper left, for how many credits you can get. And then on the right is from the code. So based on the type of building you have, the on-site renewable energy system must be sized to either the kBTU per year that building load, or the I'm sorry, that's what the renewable energy system size would be, or kilowatt hours per year. Those are the same values. They're just showing however you want to calculate your building load depending on the renewable energy system. So either the number of kilowatt hours per year that the PV system would need to generate, or the number of kBTU per year that say a biomass or geothermal system would need to generate. So if you hit those numbers for your building or more, you would get those credits. And there's a lot here, but there was 3 options for surface water heating in either hotels, motels, and apartments and dorms. There's 3 different options with different points associated with them. First one is using heat, sort of a heat recovery system for your hot water. The second is having higher efficiency fuel burning equipment, so up to 95% efficient. And the third option is using heat pump water heaters to heat the hot water. So Bryn, I guess I just have a couple more, but I'll stop for that question now, if it makes sense.
Sure. So Sarah asks, first question, is a residential home that's converted to a town library considered a commercial or residential under the energy code?
If it's converted to a residential space, then it would, I'll go into a little bit more detail on that.
It's a residential space converted to a public space.
So it would, I mean, the change of occupancy is going from residential to commercial, so it would be a commercial space. It's an existing building, so I've got a couple slides on this coming up actually. Some existing buildings, certain aspects of the code you would need to meet, like the lighting requirements, you would need to make sure that those meet the energy code. If the energy usage doesn't increase that much, you would not necessarily need to go in and re-insulate the whole building from the residential levels to the new commercial levels. If it's a really old building, you know, kind of like an uninsulated residential building, and you're changing the purpose of that building, then theoretically you would actually need to bring it up to the new energy code levels if it's going to use more energy than the residents did.
Okay, and a follow-up question, is a weatherization upgrade considered a renovation such that the building now needs to meet the 2020 code?
That is a good question. If you're going, there's nothing saying that you need to weatherize a building. This code is only for, you know, saying new buildings that are built need to meet these levels. So no, I don't believe so. If you are, the code says that, and I'll go into this, you know, if you're opening up a wall cavity, you should fill, you know, if it's not already filled with insulation, you should fill that with insulation. Similar up in the roof. If you're going to be weatherizing and adding insulation to the building, I don't think you need to necessarily bring it up to these code values.
Okay, and maybe when we get through a couple more slides, Barry can speak to that as well.
Yep, yeah. If I misspoke, I'm sorry, but let's moving on here. Sorry, we're getting towards the end. Building commissioning. So that is one slide here. If you've got a building with large enough heating and cooling systems, which I've got listed down below here, that building would need to have a third-party commissioning agent come in and do testing and balancing and functional performance testing of the lighting system and controls, the heating system and controls, just to make sure that things are operating properly, because that's an area where a lot of energy can be wasted if there's a complex design and it's hard to follow it for the building operators. So commissioning used to be required for buildings 50,000 square feet or more. That has now been changed to just dependent on the heating and cooling size systems. Okay, so now moving on. So after all that, that's chapter 4 of the code. After that is chapter 5, which is for existing buildings. If you have any addition that you're putting on an existing building, the addition needs to meet the energy code. So the envelope requirements, the windows, any new HVAC equipment you're putting in, hot water, and lighting systems. Any alterations to an existing building. So basically the code states that an existing building cannot be less conforming to the code than it was before the alteration. So basically what that means is items that need to meet the code are any new envelope assembly. You know, an alteration might include some new portions of a building, so or new walls that go up. So those would need to meet the energy code. Any new, if you're replacing a boiler or some other heating or cooling system, the new equipment should meet the energy code. Same with your hot water systems and your lighting systems. If you're pulling out the lighting, then the new lighting should meet the energy code requirements. And it specifically states that these are alterations that you do not need to bring up to the energy code. So if you're installing storm windows, if you're putting a window film on single pane glass, again, if you're exposing a cavity, a wall cavity or floor ceiling cavity that is already filled with insulation, then that does not need to be brought up to the energy code levels. It's not saying that you need to take a wall cavity and tear that off and bring that up to code if you weren't planning on removing or exposing that cavity in the first place during that alteration. So If it's there and it's not being touched, then you can leave it as is. If you're replacing existing electric resistance, you can do like with like and still put those in. That's kind of one of the few areas you can use that. A roof recover, which is just leaving the existing roof covering and installing something directly over top of that. That does not, you don't need to increase your insulation levels if you're doing that. And similarly, the air barrier does not need to be updated if you're doing a roof recover or replacement. And then any repairs to buildings, again, the code states that these items do not need to be brought up to the code levels. So if you're keeping your window frames, but you're just replacing the glass, that doesn't need to meet it. A roof repair, air barrier on the roof, if that's being repaired. A vestibule on an existing door, you need to, you don't have to bring that up to the new vestibule requirements, but if there was a vestibule, you can't remove one and not replace it with another. And if you are replacing bulbs and ballasts for, say, fluorescent lighting, you wouldn't need to bring that up to code levels if you're just changing those out, if you've still got some in your buildings. So just a couple more here. After that, it also states, so I think we're talking about this, change of occupancy or use. So if a building, if you change the type of occupancy, say you're going from like a warehouse to office space, the warehouse is pretty low energy use because it's not heated or cooled that much or at all. If the change of use is going to result in an increased demand of both fuel or electricity, then it says you should meet the energy code requirements. All of them. So envelope, lighting, all of that. And as Barry mentioned, I thought I had this earlier, but you can submit a exemption to the historic building preservation of the state, where if you can demonstrate that complying with the energy code would threaten, degrade, or destroy the historic form of the building, if they agree with you, then they can give you an exemption to not meet the energy code for at least certain portions of the code, whichever items you think would harm the historic nature of that building. And yeah, I've just got a couple useful links here for where you would send that. And again, that is listed on the what Barry shared on the Public Services website. That form is on there. So there's the disclaimer again. I won't read it again. And here is, we've got the Energy Code Assistance Center email here. So that actually will be directed to a few folks, including myself at Efficiency Vermont, who can answer code questions for specific buildings or just in general about certain requirements if you're digging in a bit deeper. So that's what I would point out if you need some additional resources. I think if you want some copies of the code books as well, calling or emailing the Code Center, we've got some that we can send out so that you could have hard copies if you would like them, as opposed to online. So that is what I have so far. Bryn, was there anything else, or did Barry want to chime in on anything at the end here?
Just if Barry wanted to just cover Sarah's questions about existing buildings being converted from residential to commercial use, and then whether or not weatherization of existing buildings would trigger code.
Yeah, well, as Charlie said, moving from our residential classification to the town library would change it to a commercial building. So you would have to look at meeting the provisions within the commercial code. Obviously, there's a few potential exemptions. Moving from a home to a library may result in not using as much energy. Possibly not, I don't know. you'd have to look at that. So you could potentially not have to actually meet the code because you're less energy intensive. But other than that, then yes, you'd basically have to meet the provisions within the code. If it's an older building, then perhaps it could fall under the historic preservation exemption as well. Yeah, that'd be something to explore. But generally, any change of occupancy such as that would mean that would become a commercial business or considered a commercial business. As to the weatherization piece, I somewhat disagree with some of what Charlie said. Basically, weatherization, it really depends on the elements that you're doing. For instance, if you're just doing air sealing, stuff along those lines, then that doesn't really impact the code. However, if you expose a cavity, or if you're in the attic, for instance, and you're adding more insulation in there, you would have to meet the requirements in an attic space. As Charlie mentioned, that if you open a wall and you're going to be adding more insulation in there, the requirement is you either meet the code or you fill that cavity as best you can with insulation. Even if it doesn't meet the code requirement, we don't require you to build your wall out in order to meet those requirements. But as I said, no, generally, if you're doing weatherization, it really depends on what aspects of weatherization you are doing would influence if you would need to meet the code in those particular sections or not.
Yeah, Barry, I think that's what I was thinking of, is if you had a wall that was a 2x4 and you actually need a 2x6 filled with insulation to meet the new code requirements, where you don't need to go build a 2x6 wall.
Yep.
Inside of that instead. So just fill that, and then, but where possible, meet the code levels. Thank you for that clarification.
Great. We don't have any other questions at the moment in the chat, but if there's anybody that's still on the line that wants to just raise your hand or ask Charlie or Barry questions, I've posted in the chat where the recording will be found and where the slide deck will be posted as well once we get that compiled. So those will probably be available on our website within the next week, at least, just to give our web team a chance to process that request and get it loaded. But as Charlie mentioned, you can always reach out to our energy code support group through the phone number or the email address, ECAC email at BEIC.org, or give us a call, and we'd be more than happy to answer your questions, provide additional resources for you and in your towns and energy committees. So just let us know. And I guess other than that, without any other further questions, we can leave it at that for today. So thanks to Charlie and Barry for the presentations. Those were great. And thank you to the attendees that found time to join us today. So thank you so much.
Great. Thanks for attending, everyone.
Thank you very much.